Hey everybody, welcome to lecture 14. I'm actually recording this lecture. Dr. Roy asked me if he wanted to see some of our lectures, so he asked me to record one, so we're going to record one. If you haven't marked yourself present in Blackboard, you know how to do it. It takes you over to EdStem. There's one additional question in there just to get a signal for Darian if you're going to attend Darian's office hours, or if you're going to attend her resume workshop. Just let me know. Yes, no. Today's agenda, I want to go back to something we finished up with on Friday. The concept of identity, that was the is and is not stuff. I kind of rushed through that a little bit. So I found a tool that might make it a little bit easier to understand what's going on there. Then we're going to get into chapter 5, while loops. So we'll probably get up to maybe 5.4 today. We'll get into 4 loops on Wednesday. So this is the agenda for today. So as a reminder, we ended on Friday looking at is and is not, which was similar but totally different from equals equals, right? Where we looked at the memory location of a object. So we're going to use a different tool today, and that tool is called Python Tutor. So if you want to take a look at that, you're welcome to run over, take a look at it. So what we're going to do here is we're going to see code on the left, and we're going to see what it actually looks like in memory from a pictorial perspective. So if you remember what's in the EdStem assignment for identity, we were looking at a bunch of lists and dictionaries related to the NFL, the AFC, and the NFC. So just to simplify it a little bit, I was representing win, loss, and tie as a list. So here we have a win, loss, tie record. In memory, what this looks like is we have win, loss, tie record of variable, and that's pointing out into memory some list. So that list is sequential, indexed from 0. Next, I'm creating a dictionary called NFL. It has the key Pittsburgh, and I'm going to point at that list. So conceptually, what's happening here is we have now another variable called NFL, and that's pointing at a dictionary of memory, but that dictionary value is pointing at this list that already exists. So there's not a new list in memory, it's the same one. Because of that, if I were to say, and pardon, maybe I skipped over that 6, let me go back to there. Here, I'm creating another list called AFC, and I'm putting one element in that list, which is this NFL Pittsburgh record. So again, you can see here I have a variable AFC. It's pointing at some list that only has one element, and the first element of that list is also this list. So because of that, if I were to update using my dictionary, so I'm saying my dictionary, well, I'm pointing at the list. I'm going to update the thing at index 1. So watch that 220 up in the right. When I execute line 10, it now becomes 230. So whether I am using the WLT record variable or the NFL variable or the AFC variable, they're all going to see that same thing if I try to access them. Here, you can see I'm going to do an update this time from that AFC record. So the AFC was a list of one element. So I'm saying access index 0. That effectively gets me this list. and I'm going to say update the thing at index 1 to 4. So watch what happens to that 230. Now becomes 240. And then finally, let me just take that dictionary directly and say, dictionary, update this to, now this is a little bit different than those other patterns. But watch what happens here. I'm not going to update this list. I'm going to say assign as the value of NFL Pittsburgh a whole new list. So look at what happened there. All right, so this is where we were before. Pittsburgh was pointing at this same list that WLT record was, that AFC was. But here, I'm creating a new list on the fly. And so now, these other records are all pointing at that same list, except this Pittsburgh value. That's now pointing back here. So, if you want to use this site, Python Tutor, right, get very comfortable with this, right? This is what's going to distinguish, like, good programmers, dare I say, from great programmers. Programmers can write code, great. Great programmers understand what that code's doing and how it's storing things in memory. This becomes exponentially more complex when we deal with something called multi-threading. Once you get into a more complex program, you don't just have one flow of execution. Like, typically, we've been working with an interpreter that goes line by line by line by line. In most computer systems, you have multiple threads running simultaneously, executing different parts of the code. Has everybody heard the term like dual core processor or multi-core processor? So there are, in most cases, doing parallel processing is done virtually, but when you have multiple cores in your CPU, you can actually do things in parallel without doing it virtually. So have a look at this, get comfortable with this. It'll help you understand that concept of identity a little bit better, and is and is not. Okay, so let us get into chapter 5, while loops. So what is the concept of a loop? Because we're going to learn different types of loops. There's for loops, there's while loops, so the two primary ones. There's different flavors in different languages, but those are the big ones. So what do we know so far? We know how to do if statements, right? So if we had a guessing game, yeah, question. It says I only, oh, thank you. Go ahead, refresh that. You should have it now. Thank you. Okay, so let's say we want to play a guessing game. We wanted to guess the fruit, right? So I have a static fruit declared here called kiwi, and I'm going to ask the user, guess the fruit, right? Now, you as the programmer, you know it's kiwi, but the person using this, they don't know it's kiwi. So input, guess the fruit, right? This is that diagram that we know and love we saw before, and I sort of have it color-coded here, right? So if guess what the user gave me equals the fruit, I'm going to print out you guessed it. Otherwise, I'm going to print out nice try. This is a very boring game because I only get one guess. If I want to run it again, if I want to take a second guess, I have to restart my program, right? So this is where the concept of a loop comes in. So the syntax here, and we'll go into a little bit more detail, looks suspiciously like an if. So if I flip back, right, I have this new syntax here. So, well, let's start up here. I still have my condition, fruit equals kiwi, and I'm still asking the user, hey, guess the fruit. So someone puts in strawberries. The syntax here is while my guess does not equal fruit. So my fruit is kiwi. The guess is whatever the user put in, strawberries, blueberries, whatever. While it is not the same, I'm going to ask the user that question again. Try again. So what this looks like in this diagram is the flow comes in and says, okay, I know the fruit is kiwi, and the user guessed strawberry. So it does this conditional check. Is it strawberry? I think I have this sort of backwards. So fruit does not equal guess, pardon me. Fruit does not equal guess is true. Try again. And then I immediately come back up and do this evaluation. Then I ask the user again, and I ask the user again until the user says kiwi, at which point they guessed it, and I exit this loop. So just like with if statements, instead of if we have while, then we have a conditional. The conditional ends with the colon. One or more lines of code gets indented. Then, when this conditional gets evaluated again, if it's now true, if the guess equals fruit, so person guessed kiwi, we drop out and go to the next statement at this level of indentation that we started from. And we'll walk through the code on that, but this is generally what it looks like. Sticking with what zyBooks had for their diagrams, right? This is how we would sort of represent it. While some condition, well, that condition is true, we do the code in the middle, and we check the condition again. We do the code in the middle, we check the condition again. Once that condition is false, we leave, and our program continues. You have access to these slides. Maybe I won't go into too much details here. This is some of that more factual information you can find in zyBooks, right? But I think it's more conducive for us to go through the code samples. All right. Just as a reminder, the syntax is very simple. While there's some expression, colon, indent, all my other lines of code. What's a little bit different about if statements, in order for this to be of any use to us, it has to change. So inside of this loop, we have to somehow affect this expression so that it changes from true to false or false to true. If we don't do that, we'll get something called an infinite loop, which in most cases is not what you want. So again, just to drill this home, this is what an if looks like. This is what a while loop looks like. And a for loop will look very similar to it. So these are the syntactic similarities between if and while. We have a keyword, we have an expression, we indent our code, and we carry on. The semantic differences, though, is what's important. With an if statement, the condition here doesn't change. We hit this line of code one time, and that's it. Now, you might run the program again and hit it again, but that's a whole different story. Over here, this gets hit over and over and over and over and over again until this condition is met. At that point in time, we drop out. So that condition must change for this code to be useful. I learned something new this weekend. Inside Python, there is the concept of an else statement on a loop. It's actually quite confusing from a novice perspective. Putting on my 30 years of programming hat, I was like, wow, I really wish I had that in other languages. So there might be some usefulness to it. But for now, let's just assume else doesn't exist. As I mentioned, infinite loops are usually a bad thing. So here I have a loop. Presumably, I want to print 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and then blast off. This code actually will write 10, 10, 10, 10, 10, 10, 10, 10, 10, 10, 10, 10, 10, because nothing ever affects that condition. Nobody ever changes that variable. So this is typically a bad thing. It's called an infinite loop. Please make sure you understand what this is and study it from zyBooks. This is probably one of those things I will ask as a quiz question for you to define, or something in this space. However, not all infinite loops are bad. Who here wants to get into graphics or gaming? So for sure, you will have loops that never end intentionally. Fundamentally, with gaming, what you're doing is you're basically repainting graphics to the screen over and over and over again. You as the programmer are basically saying, effectively, paint these pixels on the screen. Now paint these pixels on the screen. Now paint these pixels on the screen. That's all it's doing. It's doing that forever in a loop. So there's a loop that's constantly running and doing that. All right, let's get right into it. Loops. Okay, so for my friends here who are chomping to get at assignment 5, mind you, assignment 4 is due coming up soon, right? We'll put the reminders up. But for people on 5, I should have this all finalized tonight-ish. So if you want the assignment 5, people who want to get onto that, I'll have it up shortly. And then I have the slides for the lecture on Wednesday. But for now, you should at least be able to see 5.1 while loops. All right, let's get into it. Part 1, the basics. Oh, and by the way, get comfortable with this. I think EdSTEM did a release. They moved the run and submit like down here. I think they're now up here. Be on the lookout for that. All right, part 1, the basics. Here is a loop that does something one time. So I have a variable called keep going with the value true. While true. Okay, so I'm going to enter this loop and print out the message doing this once. Then I'm setting the value of keep going to false. When I get to the end of this block, it comes back up. It says, well, what's the value of keep going? Well, I just set it to false, so it can drop out. That is the simplest of simple loops. Okay. I hope folks are keeping up with the reading in chapter 5. So a new concept is introduced called range, and we'll get to ranges a little bit later. This is talking a bit about the range that you already know. So I have a range of values. So here, I have a variable called I equals 0. While I is less than 3, I'm going to print out the value of I. And you can see here I'm incrementing I by 1. So when I run this code, it starts out with 0, so it prints out 0. It increments it by 1, comes back in. It increments it again, comes back in. And then when it gets to the value 3, it doesn't execute this code again, and it prints out done. Get very, very comfortable with this notation here. Plus equals, minus equals, div equals, multiply equals. This is why this is very important as a programmer. We do a lot of loops. And it gets really painful to write I equals I plus 1. One comment on I. When we're iterating, it is very common practice to use the value I to mean iterator, I. So you will often see that. That's kind of like the one place it's okay to have a crappy variable name. So when we iterate, this is typically considered acceptable practice. And usually I is the outermost loop variable, and then the inner one is J, then you do K, then you do M as you loop inside and inside and inside. Okay, so especially with while loops, the benefit with this is interactivity. This is why we learn how to get input from a user, or we take it in. I put input in our unit test, that sort of stuff. So here's a very simple case. I'm going to ask the user, how many times should I loop? So I'm initializing I to 0. Well, I is less than whatever the user puts in, print this out. Okay, so let's put in 5. 1, 2, 3, 4, or pardon, 0, 1, 2, 3, 4. I started at 0. Okay. Run this again. There we go. Let me take limit this time. Now let me set it to 0. Nothing happened. Hopefully that's obvious, because I is 0. I entered in the value 0. Is 0 less than 0? No. So it doesn't execute this code. Interspersed activity. So instead of just asking at the start, hey, human, how many times do you want me to iterate? Here, I want to go an unknown number of times. I don't know how often I should go. So here, I'm going to start off a loop and say keep going is true. And I'm going to ask the user, should I keep going? And if they enter in Y, I'll stop. So should I keep going? Yes. Should I keep going? Yes. Should I keep going? Yes. 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 This time I'll just say no. My program will exit. This is how we get into writing interactive programs. You're going to find in the assignment 5, I'm going to have you write like a menu system where the user can be prompted over and over and over again, right? And so you might test it just 1 or 2 times. I'm going to run the test with 30. I'm going to go in 30,000 times, something like that. This, I think we looked at, but loops that don't start, right? So again, that might be a valid case. So here, I is equal to 0. If I enter in -1, it never goes into this code. And then finally, here's some infinite loops. So I'm going to ask the user to input a value. While 0 is less than this value, I'm going to print something out. Okay, let's go for it. It may look like my screen is not doing anything. It's printing 0 over and over and over and over and over and over again, right? You see the cursor moving a little bit. Be cognizant of that. Watch out for these infinite loops. zyBooks handles it a little bit differently than EdStem. At some point, the program is going to give you a warning message. It might say like Stack Overflow or out of resources or out of memory, things like that. A lot of times that means you have an infinite loop, especially when we're playing around here. All right. Just like with if statements, with conditionals, and we saw this in the lab, definitely saw this in the homework, and you saw this in the assignment 4. We can nest while loops, we can nest if statements inside while loops, we can nest while loops inside while loops, we can nest while loops inside if statements, ad infinitum. So here's a little program where I'm going to say, I'm going to ask the user, they're going to give me a number, and, or sorry, they're gonna ask me if I'm gonna keep going like we did before, and I'm gonna just increment I, and if I is even, I'm gonna say even. If I is odd, I'm gonna print odd. So should I keep going? Sure. 0 is odd. 1 is even. 2 is odd. 3 is even. That looks funny. So it sounds like we have a semantic error here. Let's take a look here. Yes, this is our problem. This should equal 0. Let's see if that fixes it. 0 is even, yes. 1 is odd, yes. 2 is even, yes. 3 is odd, 4. All right, so the program seems to be working. All right. Your turn. Let's write a little program. So let's say we have usernames and passwords. This actually isn't far off from the way usernames and passwords are traditionally implemented on computers. The only difference is, in an ideal world, the password's not stored in plain text. You normally do something called hashing. We're not going to get into that in this class, but happy to talk to anybody about it if you're leaning towards the cybersecurity world. So I have a dictionary here, which has username, and it has their associated password. Okay. Ask the user for their username and password. Check if the username is in the map. If not, tell the user to try again. If the username is in the map and the password matches, say access granted. If the username is in the map but the password doesn't, print try again. Repeat this up to 3 times. After 3 times, basically, we're going to lock the user out. All right. Now that we're getting into loops, by the way, and I mentioned this to some people at the beginning of class, the instructions for these programs, they're going to be less part 1, part 2, part 3, part 4. Metaphorically, again, I keep going back to this. So far, I taught you letters, and you learned to take letters and write words. And then I taught you how to write words and put them into sentences. And now we're putting sentences into paragraphs and paragraphs into programs or books that we're writing. I kind of had to go very, very prescriptive with those first few steps, right? But now, if I started being that prescriptive with these programs, it would be as if we were in a history class. And not only did I say, I need you to write that history paper on World War II, but I kind of told you, I need you to write that history paper on World War II on this specific general. Even worse, I need you to write this history paper on World War II on this general, and I need you to use these 4 sentences in your answer or in your paragraph, right? It really would, you wouldn't have any creative freedom in writing that paper. So here, you're going to have to bounce around between these parts sometimes. So let's get started. Let's ask the user for their username and password. So this stuff we know. I'll ask for a username. Oops. Input. And I will ask for a password. And again, I implore everyone, baby step it. The program doesn't do much, but at least I know that part works. Okay. Check if the username is in the map. Okay. If username in, what did I call this thing? UN to password map. And again, take advantage of what the IDE gives you. Right? I just started typing UN, it's giving me my answer. I just hit enter. So if username in my map, okay, what did I want to do? Print access granted. Cool. All right, baby step into it. Username, Dan. Access granted. Cool. Let me try something else here. And. Nope, didn't print out access granted. Okay, seems to be good so far. If the username is in the map and the password matches print access granted. Now I have two choices here. One choice is I can take this at face value and I can say if username in username to password map and username to password map username equals password, print access granted. And actually, pardon, I think I misread this. Check if the username is in the map. If not, tell the username try again. So let me take a step back because I'm kind of breaking my own rules here about taking baby steps here. The only information I really know so far is the inverse of that. Like I really know if username not in username not in password map, type try again. Let's just run that scenario out. Try again. Okay, cool. Now let me do my if condition. If the username in username to password map and the passwords match, print access granted. All right, so let's take a look at that. Username Dan, password whatever. Nope, that didn't work. Oh, but now we're checking the password. Cool. Let's take Dan. I think I did 1, 2, 3. Let's try 1, 2, 3. Access granted. All right. There's a little bit of an optimization here, and please pay attention to this. This is where, as we start moving forward, you'll likely start seeing, like, we take off a couple points, style points here for complexity. We really don't want to repeat logical checks. Anybody who's going to get into things like embedded systems, it's going to be very important because you might only have a limited amount of memory. You might have like a little square battery, and every time any instruction runs, you're going to chew that battery up. So you kind of want to be efficient with your coding. So I actually should realize here, if username not in this is actually the opposite case of username in this. So I really probably want to do something like this, do an else here, and then maybe do my if statement here. Okay. Let's make sure we didn't break anything. Dan, 1, 2, 3, access granted. Try that other case again. Garbage, garbage, try again. Dan, and then some other password. Okay, so we don't know what to do there yet. That's step 4. If the username is in the map and the password does not match, print try again. Cool, so that's now this case. Okay, so now I do Dan. All right, cool, try again. All right, so far we haven't applied loops at all. We've just done what we learned in chapter 4. So now it's time to make our program even more interesting, right? So now we see we have step 5. Repeat the above up to 3 times, okay? To date, you might be tempted to say, okay, well, I do that code down here. Well, you're not going to do that code down here because I want you to repeat all of this 3 times. So I'm actually now going to come up here and I'm going to say, okay, what's my max number of tries? Max tries equals 3. Okay. And I'm going to say current try equals, let's just say 1. Not sure if it's 0, not sure if it's 1, we'll find out. So while current try is less than max tries, and now I have to be careful. You take all this code here and indent it. Just like if statements, I got to indent all that good stuff there. Okay, so while current try is less than max try, and I want to be careful here, right? I only want to do, well, if I don't update current try or max try, this will be an infinite loop. This will kind of just go on forever, right? So I'm going to want to say current try plus equals 1. All right. I now need to take this code up here, though, and push it inside this loop as well. If I didn't do that, right, this value username is never going to get updated, or this value password is never going to get updated. So let's take this good stuff out of here, drop it in here. So I would recommend here, this is where you can see adding comments would be super helpful, right? So I can say here, whatever this was, part 5, repeat 3 times. This is part 1, get username / password, right? This was part 2, check if username in map. This is part 3, check if password match. And this is part 4, password no match, something like that. All right, let's roll the dice. Username, Dan. Password, 123. Access granted. Username, that's a problem. I gave my password. Access should be granted. Why are you asking me for my password again? So let's keep that in the back of our head. Let's try something else. Dan, I know the password's 123. Let me try something else. 567. Try again. Dan, 567. Try again. Oh, interesting. It ended this time, but it ended after 2. So one of my numbers is off. This is what I would do in real life, folks. Well, it's off by 1. Let's just change that. Dan, 123. Access granted. Okay, so we still have that problem. Let's try Dan. Garbage. Dan. Garbage. Dan. Garbage. Try again. Okay, so that part of the program worked fine. Cool. What are we going to do about this access granted thing? I know. I'm going to do a compound condition. I'm going to say access granted. I'm going to set that to false. And I'm going to create a compound condition. If username, pardon me, while current try is less than max try, and access granted does not equal true. And then down here in access granted, I'm going to say access granted equals true. Let's see. Uh-oh, access granted not defined. Doot. I got to move that out here. Okay. Username, Dan. Let's try this case. 123. Access granted and my program ended. Cool. Let's see if we didn't work anything else there. Dan, 456. Dan, 456. Dan, whatever, 456. Oops, I screwed up my test case. Let's try that again. Dan, not the right password. Dan, not the right password. Dan, not the right password. Exit. Cool. So that stuff's tracking. Okay. So I think we have this all working except this last bit 6. After 3 times the username password does not work, print out, try again in 15 minutes. Okay. So I have a couple choices here. And again, this is where you as the programmer can be creative. This is where you write your own paragraph if you want. I'm going to do this. Outside, I'm going to say, if access granted, well, I'm going to say actually, if not access granted, print try again in 15 minutes. Let's see what happens there. Dan, 1, 2, 3. Access granted. I didn't get a dodgy message. Cool. Dan, 4, 5, 6. Dan, 4, 5, 6. Dan, 7, 8. Whoops. Bugger. Go to my test. Dan, 4, 5, 6. Dan, 4, 5, 6. Dan, 4, 5, 6. Cool. Try again. Oh no. Try again in 15 minutes. So maybe I want to put in some patch code here. Maybe I'm going to say here, if current try is less than, what was it, max try -1. See what that does. Dan, bad password. Dan, bad password. Dan, bad. He screwed up the damn code. Dan, 4, 5, 6. Dan. Oh my gosh, I did it again. Cool. Now I have a nice message. Try again in 15 minutes, right? And there's a lot of other things you can do. Instead of doing that, maybe you wanted to just do it here. So I can put that here instead. Roll the dice. And try again in 15 minutes. That worked just as well. Got the same result. So, like I said, this is where you can get creative a little bit. One other thing I'm going to introduce here, and we'll get to this a little bit in more detail, the concept of break. So anybody who did the reading here, instead of doing this complex gobbledygook, there's the concept of a break statement. And I'll bring that up. 1 second, let's see. You know, I'm going to stay out of the slides for a minute. Instead of having this compound expression to check in my while loop, I can just use the word break. And break, as its name implies, breaks out of the loop. So as I'm iterating here, if access granted is true, this statement here says immediately exit this loop. It's a very, very, very bad thing in older programming languages called a go-to statement. This is like that, but it's socially acceptable in programming, so we use it. So let's just test this and see what this does. Dan, 1, 2, 3, access granted. There's an inverse function continue, which we'll go into detail later on. All right, so back to the deck. Share. What did we cover today? We went through identity and we looked at that Python tutor. So again, I highly recommend you get familiar with this. The nice little tool. You just come in here and on the left-hand side, you can say edit the code and you can write, whatever code you want. And then you say visualize execution, next, next. You can see what's going on. We looked at while loops, right? We compared if versus while. We said that the condition is relatively static, but with while loops, it has to change. We talked about infinite loops, and we did that little code along in EdStem. So what's coming up tonight? If you haven't knocked out Lab 4, please have that finished by 11. I'll pull the grades after that. Tomorrow night, I'll grade homework 4 at 11, so you still have a little bit of time to get that done. Thursday at 11, assignment 4, branching is due. If you have any questions, please come to office hours with me or the TAs. I would not rely on doing assignment 4 in lab on Thursday. We will be doing loop lab. Friday, we'll have a quiz on chapter 4. Homework, please try to get through 5.5 to 5.10. And assignment 5 on loops, I'll have that finished probably tonight for people who want to get started early. All right, everybody, have a good week, and we'll see you on Wednesday. Yeah.
Of course.